Welcome to the factors lesson. Factors are our special data structure for categorical data. By the end of this lesson, you will be able to explain why factors are needed, create factors with the factor function, retrieve and modify factor levels, tally and sort factor levels, and work with ordered factors. Let's begin by looking at the three main types of statistical data: identifiers, quantitative data, and categorical data. Identifiers are unique labels like passport numbers or IP addresses. Quantitative data are numeric measurements, such as area, height, or temperature, that support arithmetic operations. Categorical data are group labels without inherent numeric or lexical meaning, such as region, sex, or survey responses. While identifiers and quantitative variables use plain character or numeric vectors, categorical data benefit from a structure that enforces valid categories and preserves semantic meaning. That structure is the factor. Let's contrast a character vector with a factor. R has built-in data on U.S. states. The state.name object is a plain character vector of state names. In contrast, state.region is a factor of region labels. Notice two clues: the printed factor values are not enclosed in quotes, and a levels line appears at the end of the output. These features reveal that state.region is a factor, not a character vector. Imagine the fictional coffeehouse chain Stella Dellari offering drink sizes Modesto, Regolara, Pomposo, and Colossal. The first four customer orders are Pomposo, Colossal, Pomposo, and Regolara. We create a factor of these orders with the factor function, as shown here. By default, R sorts the levels alphabetically and only includes categories seen in the input. To include every possible category, even those not observed in the data, we pass the levels argument to factor. Because Modesto appears in the levels argument, it is now included in the console output, even though no customer ordered a Modesto drink. If you supply a vector containing values outside the defined levels, R replaces them with NA. In this example, minusculo appears in the volumes vector but not in the levels, so the corresponding output is NA. You can inspect a factor's levels with the levels function. For our sizes factor, calling levels, sizes, returns the vector of defined levels in the order we specified upon input. The forcats package offers convenient tools for many factor-related tasks, such as renaming the levels. With fct_recode, you can, for example, map Modesto to M and Pomposo to P, creating a new abbreviated factor. When multiple categories should be combined, use fct_collapse. For example, here we merge Pomposo and Big into a single P category. To lump less important levels into a single category called Other, use fct_other, keeping only the most relevant labels. To demonstrate additional options when working with factors, let's consider the GSS_cat data frame from the forcats package. It contains responses in the General Social Survey, a biannual U.S. survey that gathers demographic information. One of the columns in GSS_cat reports the religion of the participants. We can glimpse its structure, extract religion, and confirm it's a factor. To count occurrences of each level, call fct_count, religion. This returns a frequency table in the same order as the factor levels. To sort categories by frequency, first reorder the factor with fct_infrec, religion, then recount. The most common response now appears at the top of the table. Categorical data fall into two types. Nominal categories have no inherent order, such as nationality, species, or religion. Ordinal categories have a natural sequence, for example, Likert scale responses from disagree through agree, or drink sizes from Modesto up to Colossal. By default, R treats factors as nominal. Comparisons of factor values with less than or greater than return NA. For example, sizes greater than Pomposo yields NA because the factor has no built-in order. To represent ordinal data, create an ordered factor by passing ordered equals true to the factor function. The resulting object supports meaningful comparisons, for example, sizes underscore or greater than pomposo returns a logical vector indicating which entries exceed pomposo. In summary, use factor to create factors, levels, to inspect them, and functions from the forcats package for recoding, collapsing, and reordering. Remember that default factors are nominal. For ordinal data, set ordered equals true. For quick reference, consult the official forcats cheat sheet.